Welcome to another of my videos where I work through and explain A-level Physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer A, well done. If you want to hear my explanation of how I found the answer, please continue watching. In the core of a nuclear reactor, the mass of fuel decreases at a rate of 9 times 10 to the minus 6 kilograms per hour due to nuclear reactions. What is the maximum power output of the reactor? Well, the reason the reactor is producing energy, is because its mass is decreasing. It's converting its mass into energy, or its rest energy into another form of energy. So if we know how much the mass decreases by, we can find out how much energy is produced by using that most famous of all equations, E equals mc squared. Energy equals mass multiplied by the speed of light squared. So the amount of energy that is released each hour is going to be the change in mass, which is 9 times 10 to the minus 6 kilograms, multiplied by the speed of light, 3 times 10 to the 8 meters per second, all squared. Put those numbers into your calculator and you'll find that the answer is 8.1 times 10 to the 11 joules. A very little bit of mass can produce a lot of energy. But of course, that's the energy produced in 1 hour. The power of any system is given by the amount of energy per unit of time. And of course, we're always going to use standard units, and standard units of time are seconds. So the power output is 8.1 times 10 to the 11, the amount of energy that's given out in the amount of time. Well, 1 hour is 3,600 seconds, and you'll get an answer of 2.3 times 10 to the 8 joules per second, which is watts. Answer A. If you found this useful, please press the like button. Please also share the video with other people, and I hope you'll watch more of these in the series. Thank you.